Hello, everybody. We are looking at section 3 of our topic 14 notes, and this is not going to be a long section of notes. So let's just get it rolling, get it done, and out of the way. Okay, we're looking today at the volume of a pyramid. Okay, and a lot of this section I think is going to remind you of topic 14, section 1, where you have to find the area of the base and then multiply it times stuff. Okay, that's exactly what we're doing. Okay, on a pyramid, the first thing you need to do before you can find the volume, you have to find the area of the base of that pyramid. Okay, remember that the base is what is down at the bottom, what all of the triangles that fold up and meet each other at one point, all of those triangles are attached to the base down at the bottom of the pyramid. Okay? So, in this formula for the volume of a pyramid, this capital B is the area of the base. Okay? That is important information right there. Capital B is the area of the base. So whenever I refer to capital B or whenever I refer to an area, that is what I'm talking about right there. This formula is volume on a pyramid equals 1/3 times the capital B times the height of the pyramid. Okay, the height of the pyramid is exactly what it sounds like. Okay, it's how tall is the distance from the tip, the point at the top of the pyramid, dropped straight down to the middle of the base. All right, and that's our formula: 1/3 times capital B times height. All this business about the cone, that's not bad information. It's not incorrect, but we're not actually going to be dealing with that until next week. All right, so let's move on now to our examples. All right, the first thing we need to do is find the area of the base. It tells us this is a rectangular pyramid, so we're just going to find the area of this rectangle. Here, let me outline it here for you. We're going to find the area of this rectangle that is at the bottom of the pyramid. Okay, and that rectangle is 6 centimeters by 4.5 centimeters. The area of a rectangle is just length times width. So that means our capital B is length times width, which is 6 times 4.5. Our capital B here ends up being 27. That is the thing that we're going to plug into the formula right there for capital B. Okay, the other number that is given to us in this diagram is the height. It's the length of this line segment right here that goes from the point of the pyramid, dropped straight down to the middle of the base. It is 8 centimeters. So if we're plugging things in, 1/3 times capital B times the height, 8. All right, we plug all of that good stuff in. We get a total volume of 72 cubic centimeters. Okay, 72 cubic centimeters. Even if you didn't have a calculator, you could just go 1/3 times 27 is 9 times 8 gives us 72. All right. So there's our first example. Y'all, let me tell you a secret. All of the pyramid problems that we have today are pretty much like this. All right. Let's take a look at this next example. The base of a pyramid is a right triangle. Okay, the right triangle has a base. Just the triangle has a base of 5 and a height of 3. It also tells us this in the diagram down here. The triangle down at the bottom. The two legs of that right triangle are 3 and 5. Okay, the pyramid has a height of 6. What is the volume, it's asking? So we first find our capital B. Our capital B is the area of the base. And since it's a triangle, we have to do 1/2 of BH. Okay, where your base and height, that's what the 5 and 3 are. That's what it told us up in here, and that's what we have in the picture, 5 and 3. So 1/2 of 5 times 3 gives us a capital B of 7.5. When we plug that into this formula, we have to have our capital B of 7.5. We also have to have our H. Our H is the height of the pyramid, which is 6. So 1/3 times 7.5 times 6 gives us a whopping grand total of 15. 15 cubic centimeters on this pyramid right here. Go on now to our last one. I want you to pause the video, work this one on your own, and then we'll come back and compare your answer to my answer. All right, for the base, for our capital B, I'm looking at a square with a side measure of 5.5. So the area of that square is going to be 5.5 times itself. Okay, 5.5 raised to the power of 2, 5.5 squared. That's why they call it squared, y'all. It's because it's the area of a square. So our capital B ends up being 30.25. We plug that into our 1/3 of capital B times h. Remember also that your h, that height, is 12 meters. It's given to you right there in the words. So 1/3 times capital B times h gives us a total volume of 121 cubic meters. As I said, this was not the longest or craziest batch of notes that we've ever had, but if you're having trouble on the assignment, let me know. We'll get you fixed up, all right? That's all we're going to have for today. Y'all have a good one.